In this video, I'll be helping you with the ALEKS problem type called finding the foci of an ellipse given its equation in general form. And to do so, I'll first convert this equation into standard form as it's written here. And of course, the a squareds and b squareds could be switched. We won't know until we actually get it in general form to see which one is larger. But to convert this general form into standard form, I'm going to need to complete the square. And once I complete the square, that's going to give me these two perfect squares that I need for standard form. I'll start by rearranging these values to put the x terms together. We have 9x squared and a plus 18x. So I just move those to be beside each other. And then doing the same thing, I have y squared minus 6y. We just move those to be beside each other. In standard form, the constants are going to be on the right-hand side. So I'll go ahead and add that 18 over to the right. And from here, I'm almost ready to complete the square. For the x term, though, I need the leading coefficient to be 1. So I'll first factor out a 9 from both of these x terms. And now I'm ready to complete the square. For the x portion, I would take half of that middle term, so half of 2 is 1, and square it. I need to add 1 inside this parentheses, but notice that I have really added 9 because that 9 outside would be distributed. If I'm going to add 9 to the left-hand side, I must also add 9 to the right-hand side. And then for the y's, I don't have that leading coefficient factored out. So completing the square, I would take half of the 6, which is the middle term. That would give me negative 3 squared is 9. So here I'm adding a 9. And again, if I add 9 to the left, I must also add 9 to the right. From here, we can rewrite the x portion here is now a perfect square. This is x plus 1 quantity squared. The y portion is also a perfect square. This is y minus 3 quantity squared. And on the right-hand side, I now have 36. So we're much closer to standard form. Looking back at our example, we can see that that right-hand side must be 1. So to make this a 1, I would need to divide by 36, and that would mean dividing each term by 36. So simplifying once again, 9 goes into 36 4 times. So this is x plus 1 squared over 4. The y minus 3 squared is over 36, and the right-hand side is 1. We now have standard form. And before I can find the foci, I need to find the center of this ellipse. The center is the point HK. And standard form says it's x minus h, so h is a negative 1, and y minus k, so k is a positive 3. We found the center, and from here I need to know if it's been stretched up and down or left and right. Since the larger denominator is under the y, I know that this ellipse has been stretched vertically, and so my foci will be above and below that center. And since this distance is c above and below the center, our relationship is that c squared equals a squared minus b squared. So here a squared is 36, b squared is 4. So c squared equals 36 minus 4 is 32. C would be plus or minus the square root of 32. Since c is a distance, we'll take the positive. 32 simplifies into 16 times 2, so c is 4 square roots of 2. And since that's above and below, our foci are going to be with the same x value, negative 1, but I would add that distance of c to the x for 3 plus 4 square roots of 2. And my second foci would be 3 minus 4 square roots of 2. We have found both of these by converting to standard form, locating the center, and then using that center and the value c to find the foci.